We are doing page 31, and the set is 107 to 135. Determine whether the following statements are true or false. So the equation, it's odd. So 107 to 135 odd. Number 107, the equation 3x plus 1 squared equals 16 has the same solution as the equation 3x plus 1 equals 4. So regardless of if this is true or false, how would you figure that out? You could solve them both and see what the answers are. Okay, you could just square root the top one, and then you get 3x plus 1 equals, it doesn't equal 4, it equals plus or minus 4. So the answer is certainly false. How else could you solve this? Okay, after weeping, what does the guy say in, what does, Hello Dolly, what's his name? Vandergelder? Vandergelder? Weeping is a waste of water. All right, how else could we figure this out? How would you graph them to find it? And what do you need to do in order to graph them? You need to equal, it needs to equal 0 and graph it. And when you graph it, you'll find out that one of them is a parabola and the other is a straight line. And they do share one root, but the parabola actually has a second root, because when you square root this, you get plus or minus 4. So they do not have the same solution set. Let's talk about 108, even though it's not one you need to do. The quadratic equation ax squared plus bx plus c equals 0 can be solved by the square root method only if b equals 0. Right. I want to talk about 108. So if you have a quadratic equation, can you only use the square root method if b equals 0? Do you know what the square root method is? It's the complete the square. Does that only work when b equals 0? No, it works all the time. So no. Okay, 109, all quadratic equations can be solved exactly. What does that mean? If you graph it and you get an irrational decimal, is that the exact answer? No. But can you solve every quadratic equation using the quadratic formula? Yes. Are those answers approximations? No, they're exact answers. If you have square roots in them, then true. Okay. 109 was true, which is the same as 110, essentially. 111. Write a quadratic equation in standard form that has x equals a as a repeated real root. What is a repeated real root? What does it mean to have a repeated real root? 2 and 2. So it's a twice. So it's going to come down and hit at a. Well, what do we know about a? There's only one thing we know about a. What sort of number is a? It's real, which means it could be anywhere on the x-axis. It's not imaginary. So repeated means it happens twice and it's a bounce-off root. Real means it's somewhere on there. So how would I create a this is not a true or false question. Oh, I see. Okay, so this is not true or false. So how do you write a quadratic equation if a is the repeated real root? Kind of. It's x. It's not plus a because x equals a is the root. So I need to subtract this over, and I get x minus a times x minus a, which would be x squared minus 2a plus a squared. Or 2ax, thank you. 2ax plus a squared. Okay. We could do the same thing. Number 12 is actually worth talking about. If bi is one of the roots, what is the other root? What is one thing that always happens when you have two imaginary roots? Can you have 3i as a root and 6i as a root? Well, when you multiply those together, x minus 3i, plus, nope, that'd be negative, sorry, minus 6i, that's going to give me x squared minus 9ix plus 18i squared, which turns into x squared minus 9ix minus 18. Is that a graphable quadratic? No, why not? It has an I in it. So these are not options for a quadratic. What has to happen anytime you have an imaginary root? The other root has to be its conjugate. So if one of them is bi, then the other one would have to be negative bi. So it would be x minus bi and x plus bi. And that's going to give me x squared and negative bi and positive bi turn into 0, bix. And then I have minus b squared I squared, which actually turns into x squared plus b squared. So anytime you have one imaginary root, the other imaginary root has to be its conjugate. If one of the roots is 4 plus 2i, what's the other one going to be? It's 4 minus 2i. It's the complex conjugate. Okay. 13. Write a quadratic equation in standard form that has a solution set 2, 5. How do you do that? So you're going to take x minus 2 and multiply it by x minus 5. And then that 114 would be the same thing, but you don't have to do 114. Okay, turn the page. So in 115 to 121, you're just solving more generic equations. So how are you going to do 115? Times by 2, divide by g, square root, and don't forget the plus or minus. Okay, how about 117? Square root both sides. That one was easy. Okay, and then look down at 123. So you have to go all the way to 135. Show that the sum of the roots of a quadratic equation is equal to negative b over a. How do you do that? Well, okay, let me put it this way. If I had a squared plus, sorry, ax squared plus bx plus c equals 0, what are the roots? That's a tricky question. We know exactly what they are. Well, if you take this, you can complete the square. So you subtract the c and you divide by a and you complete the square and you end up with an equation affectionately known as the quadratic formula. So the answers to this are negative b plus or minus the square root of b squared minus 4ac over 2a. And that's actually two answers, right? So it says if we add those together, we should come up with the answer negative b over a. So let's try it. So let me get rid of this for a second. So if I take negative b plus the square root of b squared minus 4ac over 2a, and I add that to the same thing with the negative on it. So add it to this. If I get rid of the minus, maybe. How do I add those together? Well, in order to add two fractions, you have to have common denominator. Do I have that? Yes. So that'll make it easier. So my answer is going to be over 2a. What is negative b minus b? Negative 2b. And what is the square root of b squared minus 4ac minus the square root of b squared minus 4ac? 0. So that's minus 0. So negative 2b over 2a simplifies to be negative b over a, which until today, I didn't know that was true. But here's what it means. Let's take x squared minus 6x plus 5. How does that factor? X minus 1 and x, oh sorry, plus 1. Oh wait, it doesn't work. No, it does. If I change this. There we go. That's what I meant. So x minus 1 and x plus 1. Oh. No, it worked the first time. There we go. So my answers are 1 and 5. Well, the equation we just solved said if you take your two roots and add them together, so add the two roots together and I get 6. That's exactly the same thing as the negative of your b term divided by your a term. Is that true? If I take my b term and change its sign and I divide it by my a term, do I get 6? And that's actually going to work for all quadratic equations. Now, what does that tell us? Nothing that I know of. But you could check your answers. That's true. I guess that's a way to check your answers. And even if the answers are terribly disastrous radicals, it's still going to work. So if I had something like x squared plus 8x plus 3, that has imaginary roots, I think. Well, let's find out. So negative b plus or minus the square root of b squared. So 64 minus 4 times a times c. Oh, it's not imaginary, but it'll still work. So minus 12 over 2. 64 minus 12 is 52. So negative 8 plus or minus the square root of 52 over 2. If I add those together, so if I subtract 8 and subtract 52. This cancels that. Negative 8 and negative 8 make negative 16, and divided by 2, and I get negative 8, is the opposite of 8 divided by 1 equal to negative 8. Yes, so that always works. Aren't you just thrilled you learned that today? You could have done without it. All right. 25. How are you going to solve 25? 125? If these are the roots, what are the factors? So I need to move this over and move this over, so I get x minus 3 plus root 5. And I'm going to multiply that by x minus 3 minus root 5. Now the nice thing is, these are conjugates. They're 3-term conjugates, but they still, stuff will still cancel. Okay? And when you get to it, what is root 5 times root 5? 5. Or actually in this case it'll be negative 5. Root 5 times negative root 5 is negative 5. 127. An airplane takes 1 hour longer to go a distance of 600 miles flying against a headwind than on the return trip with a tailwind. If the speed of the wind is a constant 50 miles per hour for both legs of the trip, find the speed of the plane in the air. Okay, so we have wind blowing in this direction at 50 miles per hour. And the plane goes from here to here, and then turns around and goes this way. And what do we know about that trip? So the first, so if the return trip takes X hours, how much did the trip into the wind take? X plus 1. And it flies at 600 miles per hour in this direction. We want to know how fast would the airplane be going if the wind wasn't blowing? Oh, 600 miles. Sorry, I didn't mean miles per hour. So the trip is 600 miles. How are we going to set that up? Any ideas? Well, we're dealing with two different things. We're dealing with speed and distance. And time, I guess. So this is a time. The distance is 600 miles. What is the formula to figure out how fast you go? Rate times time equals distance. The distance for both of these is d. So how fast is the airplane flying into the wind? Some rate minus 50 miles per hour, right? So the rate for into the wind is some unknown rate minus 50. And how long is the airplane in the air? 1 hour longer than however it's long in the air on the way back. So we're going to put x plus 1 equals d. Okay. What about the return rate? The return rate is going to be r plus 50 for how long? For x hours. And how far does it travel? The same d. Okay, now what? Well, they both equal D, right? So they equal each other. So R plus 50 times X is equal to R minus 50 times X plus 1. So let's distribute. Well, wait, is that what we want to do? Let's try it. It might work. So Rx plus 50X equals Rx plus R minus 50X minus 50. Does anything cancel? Well, they're on opposite sides. So the Rx's cancel, right? If I subtract Rx, then those go away. So if I add 50X, I get 100X, add the 50, plus 50 equals R. Is that going to help us? So that equation tells you all possible times for all possible speeds, but we left out one number. We didn't use the 600, right? Or maybe we went the wrong route. So D is 600. Good. So if we go up here and we change this to 600, now I have two equations and two variables. How do you solve a system of two equations with two variables? What'd you say? Well, we tried setting them equal to each other, and we ended up with two variables, and that was a problem. Substitution. So in order to substitute, you have to have one equation equal to one of the variables. Which is the easiest variable to solve for? X in the top equation. So I'm going to divide this by R plus 50. And then I'm going to stick this stuff in here. So R minus 50 times 600 over R plus 50 plus 1 equals 600. Ooh. It is nice, isn't it? Well, I guess we'll do it. So multiply that in. 600R over R plus 50 plus R minus 50 times 600 over R plus 50 minus 50 equals 600. Get rid of this. Okay, now what? Well, let's try solving for R. I'm going to add 50. So 600R plus R over R plus 50 minus, so that would be 30,000 over R plus 50. Actually, I've got a better idea. We could solve this algebraically, but all we really want to know is, we want to know R. We want to know where this graph hits the x-axis. So instead of moving the 50, why don't we move the 600 minus 650, set it equal to 0, graph it, and see where it hits the x-axis. So 600r, or x, divided by parenthesis x plus 50 plus x minus 30,000 divided by x plus 50. Thank you. Divided by x plus 50 minus 650. And I'm going to change my window. How fast do airplanes travel? Several hundred miles an hour. So from 0, I don't know, to 700. And then I'm going to zoom 0 for zoom fit and see where this hits. Right there. So that's, if I did 700, that's probably about 250, 300. So second calc, well, I'll just do the easy way. So I'm going to go to the root, go left a couple times, go right a couple times. 250. And that saved me the effort of actually having to solve that rational expression. Now, later we are going to be solving stuff like that, but I'm sure you've forgotten it, so we'll move on. Okay, 129. Find a quadratic equation whose two distinct real roots are the negatives of the two distinct real roots of the equation ax squared plus bx plus c. Okay, so let me read that again. You kind of got to pay close attention on this one. Find a quadratic equation whose two distinct real roots are the negatives of the two distinct real roots of the equation ax squared plus bx plus c. So what are the answers to ax squared plus bx plus c? It's the quadratic formula. So it's going to be negative b plus or minus the square root of b squared minus 4ac over 2a. Okay? So if those are the roots, what are the opposites of those two roots? What does it mean, distinct real roots, by the way? What does it mean to be distinct? They're real, so they're on the x-axis, but distinct means they're not the same. So, if they're real, if the answers are real, what do you know about that equation? There's something about the equation that has to happen in order for that not to give me an I. What can't be negative? The stuff inside the square root. So we know b squared minus 4ac is greater than or equal to 0. Right? What if it's equal to 0? Are the roots distinct? Why not? If the square root is 0, what is my answer? If this stuff in here equals 0, then the plus or minus goes away, and we get negative b over 2a. Does that make sense? So in order to be both real and distinct, b squared minus 4ac has to be greater than 0. Okay? So we know that this stuff on the inside is positive. B squared minus 4ac is positive. Okay? And we want the answer to be the negatives of the two distinct real roots of the equation ax squared plus bx plus c. So we're looking for an equation whose real roots are not the same, and they're the opposites of what we get in this equation. So how do we make them opposites from each other? What would the opposite roots of this be? So if these are the answers to this, how do I make these opposite from what they are? So if I had 4 plus or minus 3, that gives me 7 and 1. So the opposites for these would be -7 and -1. How do I change this? Does just changing the b work? So -4 plus or minus 3. Does that give me -7 and -1? Yes, so if I change this to plus, do I need to change the square root stuff? No, as long as it's a real number, it's going to work. Now, when you throw in i's, that makes things different, because remember, I squared is -1, which changes some signs. So as long as this is a real number, it will work. And we know it is a real number. So if this is the answer, then what was the equation? Right. It's ax squared minus bx plus c. Does that interfere with the b squared? Why not? Negative b squared is the same as b squared. Okay? Okay, a small jet leave Atlanta at 1 p.m. Assume there's no wind. I think you guys can handle that one. And then 133. Solve the equation by writing in standard form and then factoring. Plot both sides of the equation the same viewing screen. So we want you to do x squared minus x minus 2, factor it, find the roots. Then it says, what happens if we graph this in y1 and we graph this in y2? And you have 2 questions there. And then 135, solve x squared minus 2x equals b when b equals 8 by first writing in standard form, plot both sides. So instead of factoring this, it wants you to use x equals 8. So it wants you to use this graph and this graph to find the answers. And then you're going to do the same thing when b equals -3, -1, 0, and 5. So instead of finding the answers by factoring, or by moving the 8 over and graphing and seeing where it hits the x-axis, it wants you to find the intersections of the quadratic and the line 8. Does that make sense? So essentially what's happening is if you graph x squared minus 2x equals 8, so here's my graph, this piece might look like that. It might not hit the x-axis, but x equals 8 does have 2 intersection points. Well, what happens when I subtract 8 over here? What does that do to the parabola? Moves it down 8, and now those roots become, they happen to hit in the same place that that line hits 8. Okay? All right. Good luck.